Hey guys, today I'll be walking through the solution of the following fluid kinematics problem. A two-dimensional flow field representing cooling air moving through an electronics rack is defined by U equals 0.15x in meters per second and V equals 1.5 plus 0.4 t, also in meters per second, where x and y are in meters and t is in seconds. A small tracer particle passes through the point 1, 2 when t equals 0. Determine the particle position x, y when t equals 3 seconds. It's always good to start by labeling out the given information. We have u equals 0.15x, v equals 1.5 plus 0.4t, and we're going to use the formulas u equals dx over dt and v equals dy over dt. Also, our initial conditions given by the problem are x at 0 is equal to 1, y at 0 is equal to 2, and these come from this sentence here, passes through the point 1, 2 when t equals 0, x is 1 and y equals 2 when t is equal to 0. Now we must make a substitution. We take our u here and plug it into this u in the formula. This leaves us with 0.15 times x is equal to dx over dt. Notice how this is a separable differential equation. This means that we need to get the x and the dx on the same side and then the dt on the other side. All we got to do now is divide both sides by x and then multiply both sides by dt. Doing this will cancel out this x and bring it to the dx, and then the dt will be on its own side with the constant because there's no t variable. This leaves us with 0.15 dt is equal to 1 over x dx. Now we can integrate both sides here. Integral of 0.15 dt is equal to integral of 1 over x dx. This comes out to be 0.15 t is equal to ln absolute value of x plus c. This is our general solution. Now we must find our constant using our initial condition from earlier. X at t equals 0 is equal to 1. Our x will go to 1, and our t we will plug in 0. This means that this will go to 0, anything times 0 is 0, and then ln of 1 is also equal to 0, so 0 is equal to 0 plus c, or c is equal to 0. Now we plug the 0 back in, and we have ln of x is equal to 0.15 times t. Now we must solve for x. To do this, we have to get rid of the ln. We do that by using base e. E of ln, that cancels out. We're just left with x is equal to e to the 0.15 times t, and the question asks initially to find x at t equals 3. This means that all we got to do is plug in 3 for t, so it becomes x equals e to the 0.15 times 3. Plug this into your calculator and you'll get x equals 1.57 meters. We just found our x, now we must find our y. We start out by taking our v, making the substitution into this formula, bring it down, and we're left with 1.5 plus 0.4 t is equal to dy over dt. Same premise as before, we got to get the dt over with the t's. Multiply both sides by dt, and we're left with dy is equal to 1.5 plus 0.4 t, all multiplied by dt. Now we can integrate both sides of the equation, like that, and then the integral comes out to be y is equal to 1.5 times t plus 0.4 times t squared over 2, or you could simplify, just call that 0.2 times t squared, and then there's our plus c. And just like before, we use our initial condition to find what c is. So we take t at 0 and y at 2 based on the initial condition. So we're left with 2 equals 0 plus 0 plus c, or we could just say c equals 2. Now we take our c and we plug it back into this equation here. So we're left with y equals 1.5 t plus 0.2 t squared plus 2. Now we take what the problem was asking for, we find y at t equals 3, so we simply plug in 3 to all our t's. So we're left with y equals 1.5 times 3 plus 0.2 times 3 squared plus 2. Plug that into your calculator. You will get y equals 8.3 meters. So we have our final position for y and x. So our final position at t equals 3 based on x and y is 1.57 meters and 8.3 meters. If this video helped you guys, leave a like, and I'll catch you guys in the next one.